Hey everybody, today we're going to talk about molecular complete and net ionic equations, which coincides with our solutions unit. This should be the end of our solutions unit before we move on to gases. So let's talk about what a molecular complete and a net ionic equation actually are. Well, a molecular equation shows each neutral compound as a balanced equation. So we've practiced before balancing equations. Just a regular chemical equation or a reaction where the reactants are balanced with the products. That is what we call a molecular equation. That's what we've been looking at pretty much all year long. A complete ionic equation is used to show the soluble compounds, meaning the compounds that are dissolved in water, and it shows those dissociated into ions. So this word dissociated means that they are broken apart, they are separated into their respective ions. So it's very important to refer to your periodic table to know the charges of each group of elements. And our net ionic equation is the equation used to show only the chemical species that are involved in the reaction. So not everything in a chemical reaction is pertinent to the reaction itself. Some elements, some ions are referred to as spectator ions because they aren't really part of the reaction. They just help the ions that are important get to where they are or do what they're supposed to do. And I'll show you some examples of those. Alright, so when we're going through this, you're going to need to refer to your reference chart, your solubility chart that we discussed in previous notes. You don't have to memorize these. You have this available to you. Just understand where it is and how to use it. So let's look at our first example here. Alright, my first example, I have the equation, and it tells me this is the molecular equation. Okay, so this is the type of equation that we've looked at, that we have practiced with all year long. Okay, and it says K2S potassium sulfide, which is an aqueous solution, plus cobalt chloride, which is also an aqueous solution, reacts to produce 2 moles of potassium chloride, which is aqueous, and cobalt sulfide, which is a solid. So like we've looked at before, if I've got 2 aqueous solutions, 2 compounds that are dissolved in a liquid, react to produce a solid, then what is produced here is a precipitate. So cobalt sulfide is my precipitate in this reaction. So this is the molecular equation. So we need to figure out and determine the complete ionic equation, and I'll show you how to find the net ionic equation. So the first thing we need to do to write the complete ionic equation is we need to separate each element in each compound into their respective ions. So for this, you'll need to refer to your periodic table and understand that group 1 elements have a positive 1 charge, group 2 elements have a positive 2 charge, and so forth. So looking at my first compound, I've got potassium and sulfur, K2S. All right, so I'm going to break those apart into ions. So starting with potassium and sulfur. Okay, potassium is in group 1, and it's got a positive 1 charge. Sulfur is in group 16, so it's got a minus 2 charge. So we've identified the ions. Now there's some other important information that we need to know here. Potassium here has a subscript of 2, so that tells me that I've got 2 potassium ions, so I need to make sure that I add that. And potassium is dissociating. They're now breaking apart or potassium sulfide is now dissociated into potassium and sulfide ions. Well, potassium is considered still aqueous because it's dissolved in a solution, and sulfur is also dissociated into a solution, so it's still considered aqueous. Okay, so now I move to my next compound, and I've got cobalt and chlorine. Okay, so using the reverse crisscross, this 2 here came from cobalt, so I know that cobalt has a +2 charge, and it is still dissolved in water, so it's aqueous. Plus, now again, that subscript here, 2, tells me that I've got 2 chlorines. So 2 chlorine ions, and they have a -1 charge, and they are aqueous. So now, here's my arrow. Now I move on to the right side. I've got 2 moles of potassium chloride. So that means I've got 2 potassiums and 2 chlorines, and I need to indicate that. So I've got 2 potassium ions. We already said that potassium had a +1 charge, and they are aqueous, plus 2 chlorines, which we said have a -1 charge. They are aqueous. And then the last one is cobalt sulfide, and it's a solid. So because it's a solid, it's not going to dissociate into ions because it's what's produced. So I just get cobalt sulfide as a solid. Now, what is the net ionic equation? The net ionic equation is only the part of this equation that is responsible for forming cobalt sulfide as my solid. So cobalt sulfide is what's important here. Okay. Now, to figure out what determined or what formed cobalt sulfide, I need to look on the reactant side, and I know that I needed cobalt, obviously, and sulfur, which basically means everything else is extra stuff that's not important to the equation. So things like 2 potassiums here, 2 potassiums here. We're basically canceling out the left side and the right side. 2 chlorines here, 2 chlorines here. These are all considered spectator ions because they're just there to help the reaction go along, but they are not actually important to that reaction. So my net ionic equation is just the important stuff that helped me form cobalt sulfide. So I'm going to write them in the order that they are here. So I'm going to write sulfur -2, aqueous, and cobalt +2, also aqueous, react to produce cobalt sulfide as a solid. Now, sometimes you'll see them, you may see them written like this with a negative first and then the positive second. But when you see your actual product form, remember the positive cation is always listed first and the anion is listed second. So you might also often see it written the other way, with cobalt written first and sulfur written second. Still reacting to produce cobalt sulfide. And there's your net ionic equation. So let's try another one. In 2, I've got calcium chloride react with sodium hydroxide to produce calcium hydroxide and sodium chloride. So notice calcium chloride is aqueous, sodium hydroxide is aqueous, calcium hydroxide is a solid, and sodium chloride is aqueous. So when I reacted 2 aqueous substances together, they formed a solid precipitate. So the first thing I need to do is dissociate my ions, my compounds. I'm going to break them apart into ions. So starting with calcium. So calcium is going to be broken down into Ca +2. And calcium is aqueous. I'm going to also break it down into Cl minus 1, which is also aqueous. Now, this subscript 2 tells me that I've got 2 chlorines. So it's 2 Cl with a minus 1 charge. So remember, this is dissociation. Calcium chloride has been dissociated into ions. So now I'm going to keep going. Sodium hydroxide. So sodium will break apart into, sodium hydroxide breaks apart into Na+1, which is aqueous. And hydroxide is a polyatomic ion, which is going to be grouped together, also aqueous. And then I'm going to get calcium hydroxide as a solid. So that's not going to dissociate because that's what was actually formed. So CaOH2 as a solid. And then I get sodium as an ion and chlorine as its own ion. Okay? So now I've got my complete ionic equation. The equation was dissociated into their respective ions. So now I need to figure out what was important in this equation. Okay, well, look at what was formed. I formed calcium hydroxide as my solid. So the two things that formed calcium hydroxide would be calcium and hydroxide, which means everything else is extra information. You know what? Actually, looking at this, I realize that this equation is not balanced. All right, so this should be a 2, and this should be a 2. Okay, very important. I can't believe I forgot that step. So now I need to go back and 2 sodiums. I need to put a 2 here. 2 hydroxides, a 2 here. On the right side, 2 sodiums and 2 chlorines. My apologies. Okay, so what's extra information? Well, 2 chlorines here, 2 chlorines there, 2 sodiums there, 2 sodiums there. So these ions here, again, are spectator ions. They are extra information, basically. So the important stuff, the net ionic equation, would be calcium, which is in the aqueous form, plus 2 moles of hydroxide ions, which is also in the aqueous form, reacted to produce CaOH2 as a solid. They form solid calcium hydroxide. All right, moving on. Example number 3. Example number 3, it says I've got a solution of magnesium sulfate that's added to aqueous lead 2 nitrate to yield solid lead sulfate and aqueous magnesium nitrate. All right, so we've got our molecular equation expressed out in words, so we need to write that sentence into a molecular equation that we can use to dissociate our ions. So starting here, a solution of magnesium sulfate. It's saying that it's a solution, which means it's going to be aqueous. Okay, magnesium sulfate. So magnesium sulfate. So magnesium we know has a +2 charge. Sulfate has a -2 charge. So magnesium sulfate is MgSO4. It's in the aqueous form. Okay, it's added to lead 2. So lead has a symbol of Pb. 2 means it's got a +2 charge. Nitrate is a polyatomic ion, NO3, and it's got a -1 charge. So lead nitrate would be PbNO3. 2, because it's lead 2. And this is aqueous, which means it's also AQ. And they yield, so arrow, solid lead to sulfate, so Pb plus 2, and sulfate SO4 minus 2 gives me Pb SO4 as a solid, and aqueous magnesium nitrate. So aqueous, AQ, magnesium nitrate, Mg plus 2, and nitrate is NO3 minus 1. So this is Mg NO3 2, and it's aqueous, so AQ. Alright, there's my molecular equation. So now I want to dissociate all that into complete ionic equations, or an equation. So I've already kind of done the work for you, and hopefully as you're reading this, you are also making mental notes. These are the ions. So if you're writing these along here, then this second part, the complete ionic equation, should come pretty easily. So magnesium sulfate. So magnesium sulfate dissociates into magnesium ions, so magnesium plus 2, aqueous, plus sulfate as a polyatomic ion, minus 2, aqueous, plus lead, 2, aqueous, plus nitrate, my polyatomic ion, minus 1, aqueous, breaks into lead sulfate is a solid, so it's going to stay lead sulfate. And then magnesium nitrate is going to dissociate into magnesium ions and nitrate ions. So this is 2NO3. I think I need to fix it on the other side. 2NO3, which is aqueous, and this should be 2NO3 here. So now let's figure out what our net ionic equation is. So let's see. On the product side, we had lead sulfate as my solid, which is the important part basically, is what's being produced from two aqueous solutions. So how did you get lead sulfate? Well, you had some lead and you had a sulfate ion. So those are the important pieces, which means everything else is going to be extra. So I've got a magnesium here, a magnesium here. I've got two nitrates here, two nitrates here. Again, these are spectator ions. So my net ionic equation includes everything that's not a spectator ion. So I'm going to write my cation first. I'm going to write lead plus 2 plus a sulfate ion reacted to produce lead sulfate. Now this is lead 2 sulfate, so Pb plus 2 and SO4 minus 2, the charges cancel each other out. So just PbSO4 as a solid. There's my net ionic equation. So if I looked up here at number 4, I've got a hydrochloric acid. A hydrochloric acid is added to sodium hydroxide. Hydrochloric acid is added to sodium hydroxide. So hydrochloric acid, we haven't talked about acids and bases yet, but hydrochloric acid is HCl. And it's in aqueous form as an acid, and it's added to sodium hydroxide. Sodium hydroxide. Okay, so we're missing some information, so we need to take the information given to us and complete the equation. So I'm going to start with what we do know. HCl is added to sodium hydroxide, which is also aqueous. So what's produced from HCl and NaOH? Well, your double replacement reaction that we're going to have here, you're going to have a hydrogen. Actually, you know what? Let me write this up here. So if I've got HCl and NaOH, hydrogen's positive, chlorine's negative, sodium's positive, hydroxide's negative. The positive bonds with the negative, and the positive here bonds with the negative. So I get hydrogen bonding with OH. I get HOH. And I've got sodium bonding with chlorine, which is NaCl. So there are my products. HOH, y'all should recognize this. This is water. And NaCl. All right, so NaCl is aqueous, and H2O is a liquid. All right, so now I need to write the complete ionic equation. So I'm going to dissociate hydrogen and chlorine. So hydrogen's got a +1 charge, and it's aqueous. Chlorine has a -1 charge, and it's also aqueous, plus sodium hydroxide. Sodium +1, and hydroxide -1. Produce water, so we're going to leave water as a liquid. And sodium chloride is going to be sodium and chlorine. Okay, so water is the important part of this reaction. So how do you get water? Well, you use the hydrogen and the hydroxide, which means everything else is a spectator ion. So I've got a chlorine here, a chlorine, a sodium, and a sodium. These are spectator ions. All right, so let's write the equation. I've got hydrogen plus hydroxide react to produce H2O as a liquid. All right, and my last one here. I would like you to take a moment to attempt number 5. You can go ahead and pause the video, see if you can write out the molecular equation, complete ionic and net ionic on your own, and then when you're done, come back and watch the video to check your answers. Okay, so what we have here, magnesium reacts with hydrochloric acid to produce magnesium chloride. And so let's see, magnesium is +2, chlorine is -1, so magnesium chloride would be MgCl2. And hydrogen gas, hydrogen is diatomic, so that's H2. So let's write the molecular equation. We've got magnesium, which is a solid, plus hydrochloric acid, aqueous, produce magnesium chloride, which is aqueous, and hydrogen gas. Okay, so let's make sure that the equation is balanced. We've got 1 Mg, 1 Mg, 1 H, 2 H's, 1 Cl, 2 Cl's. So let's fix that with a 2 HCl. So now I've got 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. Now we're good to go. All right, so the complete ionic equation. So magnesium is a solid, so it's not going to dissociate into an ion, so it's just magnesium plus 2 HCl. So this is going to dissociate into hydrogen and chlorine because it's aqueous. So I have, let's see, 2 hydrogens with a +1 charge plus 2 chlorines because the coefficient 2 pertains to both elements. Okay, on the right, magnesium chloride. So now magnesium is going to dissociate into an ion. And chlorine, I've got 2 chlorines, which is going to dissociate into 2Cl-1. That's aqueous. And then hydrogen gas is just H2 as a gas. So it's not going to dissociate either. Okay, so now we got to see what's the same on both sides. So I've got magnesium here, but this is magnesium as a solid, which isn't the same as Mg plus 2. This is magnesium as an ion. This is magnesium in the solid state. They're not the same. Okay, but here I've got H plus. I've got 2 hydrogens, 2 hydrogens. These aren't the same either. This is a hydrogen ion. This is hydrogen as a gas, so those are not the same. Here I've got 2 chlorine ions and 2 chlorine ions. Those are the same. So those are my spectator ions. Okay, so what's your net ionic equation? Well, we got magnesium as a solid. You've got 2 hydrogen ions. You've got magnesium ion and hydrogen gas. There's your net ionic equation.